All right. Geometry lesson 6, we're going to talk about identifying pairs of angles. A little while back, we had our introduction to angles. We know that angles are based upon two arrays that share a common endpoint. That endpoint that they share is called a vertex, just as kind of a review. But pairs of angles, a pair of angles can sometimes be classified by their combined measures. We had a later lesson, it talked about the angle addition postulate, meaning if I've got an angle that has a ray coming out of that same vertex, that those two individual angles that make up the inside of it will add up to be the whole angle, right? We remember some of that. So when we have a pair of angles are known as either complementary. These specialized pairs are known as complementary and supplementary angles. Not all adjacent pairs are complementary or supplementary, but complementary angles are a specific type of pair where they add up to be 90 degrees. So two angles that whenever I have their sum, their angle addition comes out to 90 degrees. We call that a complementary or complementary angles. This is a really important thing right here to know. It's probably not in your Quizlet slides yet, but this is one, it's a big deal. Okay, complementary and supplementary angles are a big deal. We haven't yet gotten to vertical angles. I think that maybe later on in this lesson, if not, it'll be in a future lesson. There's a couple of things that I feel like I have to continually ask students about, and students continually forget these things. They're things that you need to hold on to. You need to study, you need to memorize what are complementary angles. They're two angles that add up to 90 degrees. Okay? So if we were to look at them visually, okay, we'll take something like this. Okay? These two angles, okay, that we have, let's go ahead and label some parts here. We do this, call it A, B, C, and D. Angle ABD and angle DBC are complementary angles. They add up to 90 degrees. Do you follow me? Okay. Write it down, type it, put it wherever, but hold on to it. Complementary means adds up to 90. Supplementary. Two angles are supplementary angles if their sum measures 180 degrees. Our visual here would look like this. Okay. Okay? Supplementary. They add up to 180 degrees. Really early on, we talked about a straight angle. A straight angle looks like a straight line. It has a total of 180 degrees. So imagine a straight line with just a ray coming off of it. Those two angles, angle ABD and angle DBC, are supplementary angles. They are also what we're going to call a linear pair, because whenever I put these two angles together, whenever I add them up, they form a straight line. Okay? So linear line pair. They're two angles that create a linear pair. So we have congruent complements. So if two angles are complementary to the same angle, meaning if two different angles with a third angle, okay, so I'm trying to think of an instance here. Let me draw this out. Let's see. Okay, let's say I've got something like this. Okay? It's possible, let's see, A, B, C, D, E, and F. Okay? That angle ABD and angle DBE are complementary. Okay? So if I had something like that, okay, those two angles are complementary. Okay? And angle CBE and angle EBF are complementary. Now, that may not be a perfect example, but we could see where two angles that are complementary with the same angle, with the same third angle, are going to be complementary to each other. Okay, actually let me change this up a little bit. Let's see. Okay, if I knew that this was a right angle and I knew that this was a right angle, okay, what would be shared here is angle EBF. EBF is being shared between DBE and FBC, right? Then what I know is that angle DBE is congruent to angle FBC. Do you catch that? I know whenever I start quoting off angle names, I tend to lose people. Do you want me to go through it again? No? Because there is an overlap here that's making both of those complementary pairs, then what I know is that this angle and this angle are congruent to each other. You got it now? Okay. The same thing applies with congruent supplements. If two angles are supplementary to the same angle or to congruent angles, then they are congruent. Okay? That's the same principle, it's just with supplementary angles. All right, so let me ask you real quick, just because we're off that page, what is complementary angles? What are they? What do they add up to? 90 degrees. What are supplementary angles? What do they add up to? 180. You've got to get that nailed down. Just like it's just as much a fact, and it's just something that you need to know just as well as there's 5,280 feet in a mile, and we drive on the right-hand side of the road, right? Okay. All right, so two angles in the same plane that share a vertex and a side but share no interior points are what are called adjacent angles. So adjacent angles here are angles that are next to each other. So let's see, angle LSM is adjacent to angle LST. Okay, they share the vertex S, they share the side SL, but they don't share anything else. They don't overlap anywhere. Okay? But not only that, but if I wanted to, I could say that angle LSM is adjacent to angle LSR. Those are also adjacent to each other. Do you follow me? Okay, so they still share the vertex S and they still share the side LS. Okay, and we could come up with several different adjacent pairs there. Okay, so do we understand what adjacent angles are? Angles that share a common vertex and a side, but no other interior points. All right, so let's see, and I can ask, somebody give me a different set of adjacent angles. Give me another example. Jose, can you give me two angles that are adjacent to each other? TSR with TSL. Perfect. That's exactly right. Okay. Let's see. Can I get another example, Marcos? LSM. TSL. I feel like I did that one for you, but that's fine. Okay. Let's see. Michael, can you give me one that we haven't already done? There's probably only one more on the list. RSM is a straight angle, but it's not going to technically be adjacent with anything because it would share a vertex with the other angles, but they're going to be interior to RSM. And so they can't be interior and still be adjacent. Like it can't be inside of. So I can't say that, for instance, I can't say that TSM and LSM are adjacent, right? Because LSM is interior to TSM. You see my point? Okay? I have to be able to use the angle addition postulate, right, in some form or fashion there. All right, let's look at something else. Adjacent angles whose non-common sides are opposite rays form a linear pair. Okay? So a linear pair would be LSM and LSM and LSR. Okay, meaning that they have opposite rays. Okay, they end up forming, if I look at this, I've got from here to here, and then from here to there, what have I got? I've got 180 degrees being represented there, so that's a linear pair. Okay, so a linear pair are angles that add up to 180 degrees. Okay. All right, so we want to recall that the measure of a straight line is 180 degrees. Since a linear pair composes a straight line, the linear pairs are supplementary. All right. Theorem 6-3, this is the linear pair theorem. If two angles form a linear pair, then they are supplementary because a line is 180 degrees. Again, that's not super complex. Non-adjacent angles formed by two intersecting lines are vertical angles. Vertical angles share the same vertex but have no common sides. So just to give you an example, if I've got two lines that cross, look like this. Let's go ahead and put some points. We'll call that A, B, C, D, and E. All right, vertical angles share a vertex but no sides. They only share the vertex. So angle BEC is vertical with angle AED. They share a vertex but no sides. Okay, vertical angles. Okay, can anybody show me another pair of vertical angles that exist there? Okay, go ahead. AEB and DEC are vertical. They're opposite to each other. Okay? Now, one of the things I want you to go ahead and understand, it may not be in this lesson. Actually, no, it is. It's the very next thing. If two angles are vertical angles, then they are congruent. They will always be equal to each other. Always. So if I know the angle BEC is 65 degrees, then what I know is now I can find out what the other 3 degrees are. Because if BEC is 65 degrees, what is AED? 65 degrees. Okay? Now you say, well, how do you know what the other two are? Well, BEC and BEA are what? What are they to each other? BEC and BEA. What are they to each other? What do they form? They're adjacent angles, you're right. But look, if I go from side CE up to this one and then over here, what do I have here? What is this? A straight angle which has 180 degrees. I already know about 65 of them, so how would I find out BEA? Subtract 65 from 180, which is going to be 115 degrees. So I already know now, I know that BEA is 115 degrees, correct? Okay, so then what is DEC? 115 degrees. Okay, so in this case where I have vertical angles, adjacent pairs are supplementary. Okay, well I have two lines crossing, and if I added all this up, what should I get? If I add all of those degrees, 115 plus 115 plus 65 plus 65, what should that equal? Should equal 360. If it doesn't, I did something wrong. Okay? All right. So that's more information than maybe you need right now, but vertical angles are congruent. All right, that's it as far as that list goes. So let's look at this. See what we can figure out. Question number 1, if angle 1 and angle 2 are vertical angles, what do I know about vertical angles? This may be, in addition to complementary, supplementary, vertical angles is something I have to continually ask students about. So you'll hear me ask this question 150 times or more. What are vertical angles? You should say, they are congruent. So what are vertical angles? They are congruent. They're angles that are opposite of each other. They share a common vertex, but nothing else. So what does the term congruent mean? Same size and shape, right? Same size and shape. So if angle 1 and angle 2 are vertical, and measure angle 1 is 2x plus 16, measure angle 2 is 5x minus 35, we want to know what angle 1 is. What am I going to do with angle 1 and angle 2? Set them equal to each other. Very good. So 2x plus 16 equals 5x minus 35. Okay, this is a really important part here. What is measure angle 1? That's eventually what I want to solve. Okay, so what do I do from here? I want to get to, first I need to solve for x. Okay, help me solve for x. Jordan, what do you think? What would you do if you wanted to solve for x here? Subtract 16 from 35? Okay, that's fine. Okay, so that's going to give you 2x equals 5x. Now the tricky thing here is you've got negative 35 minus 16, so we're going further in the hole, right? Okay, that's fine now. We're just going to have a bigger negative number. All right, what's negative 35 minus 16? It'd be the same thing as 35 plus 16, except my answer is going to be negative, right? Well, negative 51. Right, negative 51. Okay, what's next? What do you have to do next? Yep, x's are next. Nope, and you're going to have to subtract. Nope, because that's going to move everything over here. So what do you want to do? No, yeah, listen, you're on the right track. I'm trying to get, if I'm solving for x, I have to isolate x, right? It means get the x's all together. So no, I'm going to subtract 5x. I'm going to move this over here. So that I can get my x's over here. Now, let me go back, okay, because I think this would have helped you out a little bit. Well, what I would have done is I would have added 35 to 16. All right, you still would have gotten 51, but it would have been a positive 51 instead of a negative 51. And then what would you do with this 2x over here? Now, if I want to get it over with that 5x. Subtract 2x from 5x. I think that's the problem that you had, is that you started getting negative numbers and you thought, I've done something wrong or this isn't going to work. It still would have worked, but you would get 51 equals what? What's 5x minus 2x? 3x. What's your final step in there to solve for x? Divide by 3. 51 divided by 3, is that like 17? 17 equals x. Okay, so the biggest mistake that people make on tests is that they stop too early. They see, okay, 17 degrees, but that's not the question it was asked, right? They didn't ask what is x. They said what is angle 1? What do I have to do with 17? Plug it in. All right, it doesn't technically matter which one I plug it into because they're vertical angles. It would be the same solution either way, right? But so we should do 2 times 17, which is 34. What's 34 plus 16? 50. So my answer is 50 degrees. Okay? That's probably as far as I want to go. We went about 5 minutes longer than I wanted to, but you get a start on your homework. Okay? Complementary, supplementary, vertical angles. Those are the big things to get here.